Hi everyone. So today we are going to learn numerical integration, an important topic in numerical methods. So numerical integration is used to find the approximate value of a definite integral when the exact integration is difficult or when only tabulated values of the functions are available. So in this class, we will learn important numerical integration methods. So in single integral, first one trapezoidal rule and second one Simpson's one-third rule and Simpson's 3/8 rule. So in double integral, we will learn trapezoidal. So before we start, let me ask you a simple question. So imagine you want to find the area of an irregular shaped garden. So can you use the area formula of a rectangle or a circle? No. So what will you do? You divide the garden into many small parts. So find the area of each part and then add them together. So this is the exactly the idea behind the numerical integration. So let us see another example. Suppose Google Maps tells you that your destination is 10.2 kilometer away. So it is not measuring every small curve on the road. So it is calculate the distance using many small measurements and gives an approximate value. So now let us study the trapezoidal rule. So in this method, we divide the given interval into several equal parts. So in the formula, y naught and yn are called the first and last ordinates. They are taken only once. So all the remaining middle ordinates, so y1, y2, etc., yn minus 1 are multiplied by 2. And finally, we multiply the entire expressions by h by 2. So to obtain the required answer. So next, we will learn Simpson's one-third rule. So this method gives more accurate result than the trapezoidal rule because it assumes the curve is a parabola instead of a straight line. So in this formula, the first and last ordinates y0 and yn are taken once. The odd number ordinates such as y1, y3, y5 are multiplied by 4 and the even numbered ordinates such as y2, y4, y6 are multiplied by 2. So finally multiply the entire expressions by h by 3 to get the approximate value of the integral. So now let us study Simpson's 3/8 rule. So Simpson's 3/8 rule is used to find the approximate value of a definite integral. So in this formula, the first value of y0 and the last value yn are taken only once. So the values y1, y2, y4 and y5 and so on are multiplied by 3. The values y3, y6 and y9 are multiplied by 2. So finally, multiply the whole expressions by 3h by 8. So now let us see the error and order of the different method. So the table compares the three methods. In the trapezoidal rule, we can use any number of intervals. So we can use any number of intervals and its order is h square. In Simpson's one-third rule, the number of interval must be even and its order is h power 4. So in Simpson's 3/8 rule, the number of interval must be multiplies of 3 and that is 3 multiples of 3 means 3, 6, 9 or 12 and its order is h power 5. So important points So always check the number of intervals before choosing the method. So trapezoidal rule, any number of intervals. Simpson's one-third rule, even number of intervals. Simpson's 3/8 rule, multiple of 3 intervals. So these conditions are very important in numerical integration. So now let us solve example 1. So we have to find the value of the integral from 0 to pi of sin x dx, and the interval is divided into 10 equal parts. Since 10 is an even number, so we can use both the trapezoidal rule and Simpson's one-third rule. Now let us prepare the table. The first row shows the x values starting from 0 and ending at pi with equal intervals of pi by 10. The second row shows the corresponding values of sin x. So these values will be used in the formula. So in the next, we will substitute these values into the trapezoidal rule and Simpson's one-third rule formulas to find the approximate value of the integral. So now let us move on the solution. So now let us solve this problem using the trapezoidal rule. So first we find the range. So how to find the range? The lower limit is 0 and the upper limit is pi, since the range is pi. Then the interval is divided into 10 equal parts. Therefore, h is equal to pi by 10. So now we use the trapezoidal rule formula. So in this formula, the first value and the last values are taken only once, and all the middle values are multiplied by 2. So next we substitute all the values of sin x from the table into the formula. So after simplifying the calculation, we get integral 0 to pi sin x dx equal to 1.9843. So this is the approximate value obtained using the trapezoidal rule. So next we will solve the same problem using Simpson's one-third rule and compare the two answers. So next, example 2. The question is to evaluate the integral 0 to 1 e power minus x square dx by dividing the range into 4 equal parts using trapezoidal rule. So the interval is from 0 to 1 and it's divided into 4 equal parts. So first we have to find the value of h. So we use the formula h is equal to xn minus x naught by n. So here x naught equal to 0 and xn equal to 1, and the number of intervals n equal to 4. So h is equal to 0.25. So next we calculate the value of y equal to e power minus x square for each values of x. So these values are shown in the table. The first one, apply the trapezoidal rule. Now substitute the values in the trapezoidal rule formula. The first and last ordinates are taken only once and the middle values are multiplied by 2. And after substituting all the values and simplifying, we get integral 0 to 1 e power minus x square d is equal to 0.7430. So the approximate value of the integral is 0.7430.